Hey everybody, we are going to find area of composite figures. This is a challenging lesson and I hope you guys persevere. It'll come. It'll come. You guys will be able to do it. Just have to take it step by step, little by little, and you guys will do great. All right. So composite figures, what are they? They're made up of two or more shapes. So what we need is we need to know the area of each of these individual shapes so that when we see a combination of those shapes, we can break it down and find the area of the individual shapes, then add them up. That's it. Find the area of the individual shapes, then add them up. All right. This up here is going to be your go-to list. You're going to be referring back to it, writing these formulas down, because these formulas tell you exactly what to look for and what numbers you'll need from the diagram that's given. All right. A little reminder about trapezoids. Trapezoids, I'm going to draw it over to the left. A trapezoid, okay, can look a lot of different ways, but just remember that the bases are the parallel sides. All right, so this would be base 1 and base 2. Now, if it was oriented differently, let's say something like this, okay, where are the parallel sides in this case? They're here. Okay, so this would be base 1 and base 2. All right, now let's think about the heights. The heights always have to meet at right angles to the bases. Bases and heights have to be perpendicular. That's another way to say they meet at right angles. Okay, so then you'd need another line here to be the height because neither of these diagonal lines here that connect the bases are at right angles. So this would be your height here. Now in this bottom case, it looks like maybe this meets at a right angle. So in this case, the actual side length, because it meets the base at a right angle, right, is the height. All right, so that's just a real quick reminder of trapezoids about what the bases are, the base 1 and base 2 are, and how to know that you're looking at the height. All right, let's go to our first example. You can read through this. I'll quickly show you some little things to be aware of. The thing I like they did is they drew the separate shape. So what they did is they cut it, took some scissors and sliced it right along that dotted line so that you have this semicircle. So you'll kind of make a part of your paper to show the work for the area of the one shape, and then you'll take the other shape and use the area of your paper to find the area of that shape. All right, let's look at this semicircle. You have to use the right formula. It doesn't say up here the area formula for a semicircle, but you might want to jot that into your notes and into your textbook. Okay, so here we go. So using 3.14 as the approximation for pi. Notice we use the approximately symbol here. And then it's asking for r, which stands for radius. Radius is only halfway across, but they tell us all the way across is 6, which is called the diameter. So we want just halfway across, which half of 6 is 3. So we're going to plug in 3. That's just one of those little mistakes that you'll make. You'll do all this work and then you'll get it wrong and you'll realize, oh, I forgot to change the diameter to a radius. So then anyway, you get the 3. Okay, type that in your calculator or do it in your head if you've got those types of skills, and you get approximately 14.1. All right. The triangle is pretty straightforward. You can see the base and the height meet at a right angle, and you just plug it into the formula. 11 for B, 6 for H, and then simplify this and get your answer of 33. Now that you've found the area of both shapes individually, we're going to add them up to get the total area of the composite figure. All right, now let's try this problem here. Pause it if you want to try it yourself, or you can just follow along with me. I'm going to first cut this across there. All right, not a very good line there, but it breaks it up into, what, 2 shapes. I'm going to show my work over here on the next page. Okay, sorry, on the left of this video. All right, and I'm going to draw my 2 shapes. I have this trapezoid and I have the rectangle. Now that I know what shapes I have, I refer back to my list of formulas and I'm going to write them down. I have a trapezoid, so that's going to be area equals 1/2 the height times base 1 plus base 2. All right, I've got that. And now I also need the area for, rectangle. It doesn't have a rectangle, but I know, and you know, that a parallelogram is another name for a rectangle. Rectangle is a more specific parallelogram that has right angles. But anyway, we're going to use base and height. Okay, let's get back to our picture. We have the trapezoid to work with first. It looks like these are the parallel sides, so they're going to be my base 1 and base 2. And I can tell that that's going to be 20 inches just by looking to the right here. Look at the picture again. I have 20 inches here. And then this isn't labeled. I put that line in myself, but I realize that it's horizontal, and the other horizontal line that's the same length as that is this bottom one. So that's going to be 25 down there. Now, I need my height. And notice up in the corner here, right there, terrible arrow, is a right angle. So that's giving me a clue as to where my height is. So I'm looking for this length right here, that little length. Now, it's a horizontal line. It's not labeled, so it's a missing length. And I have to look at the other vertical lines to help me out. So I know all the way to the top of this line is 20 inches. All the way up is 20. And I know that part way up is 13. So if I subtract those, I can get this missing piece of 7. All right, so now I have all the dimensions I need for this. I have the height, which is 7. And I have the base 1, which would be 25, and the base 2, which would be 20. When I combine those, I get an answer of, let's see, that's going to be 3.5 out there. 25 plus 20 is 45. And when I multiplied those on the calculator earlier, I got 157.5. Okay, now let's turn our attention to the rectangle. A little bit easier. If I look to my shape on the right, I have 25 on the bottom, and meeting at a right angle, I have this 13 over here. Looking here, you're going to be tempted sometimes to see a 20 hanging out by a side that you want, and you're going to just plug that in and not realize that that goes all the way to the top. That's not the length we want. We want just to there, from there to there. So that's going to be our 13. So when I plug this in, I have a base of 25 times 13, and my calculator tells me that that's 325. So now we have to add those two up. 325 plus 157.5, which gives us a 0.5, 8, and 4, 482.5. Let's see if we're right. All right, 482.5. And remember, area is always measured in square units. So I should add my inches squared there. All right, we're cruising, guys. Hopefully that makes sense to you. We're just going to do one more example. We're going to look at one example in the book and then do one more example together. All right. So example number 2. Now this is one of the trickiest ones that I've seen, just because it's not written, it's drawn in a way that, I don't know, I haven't seen many shapes drawn. Okay, so how would I cut this up? Well, it looks like we sliced it right there. Oops. Looks like we're slicing it right here. All right, and what two shapes are they? Well, a shape that has a pair of parallel sides, or two parallel sides, is a trapezoid. So this guy's over here, and just make sure these parallel sides, even though they're not sitting on them to be like a base that you would normally think of, the parallel sides are always your bases when it comes to trapezoids, okay? So what we need here is to plug in those two numbers, 2 and 3, into the base, and then you can see that indicated up here is that right angle there. Right angle right here. So that 3 is my height because it's at a right angle to the bases. All right, so you plug those in, calculate it, you get 7.5. Over here, this is really, really hard to visualize for me, and I'm sure some of you guys, but they give you this extra piece of information that's not needed. Why isn't that needed? Because it doesn't meet anything at a right angle. We need these two. These two are important because we see that this is a right angle here. Bases and heights always have to meet at a right angle. So this is a parallelogram, and we have the base is 6 and the height is 2.5, and that's what we plug in. Once we get them, we add them up. All right? Here's one to try with each other. All right, you can pause, try it yourself, see how you do, and then check back with the answer, with your answer to see how you did. All right, pause. Okay, we're back. I'm going to draw out my two shapes. I have a triangle and I have a rectangle. So I get my formulas. If you have to look back at the previous page, you can. I know that area of a triangle is 1/2 base times height, and area of a parallelogram is area equals base times height. Now, I'm going to work with my triangle first. Look over on the picture here. What I need to do is find my base and my height. Now, this isn't labeled, right? But if I look across the way here, I know a length that's equal to it, and that's 15. So now I know that that's going to be 15. And my height is labeled here. That meets at a right angle to that guy there. So my base and height are 15 and 4. So back to my work, I'm going to type those in or write those in. Base was 15 and my height is 4. If I take half of the 4, I get 2 times 15. That gives me 30. Now I got to work on my other guy. Okay. If we look over to the right here, we see the base and the height meet at right angles there. So that would be area equals 15 times 12. And I calculated this earlier to 180. And what do we do with those areas at the end? What do we do? We're going to add those up. So 180 plus 30, that gives us 210. And that's in feet, so feet squared, or square feet. Let's see how we did. Is it right? Is it right? Oh my goodness. I can't wait to see. Yes, we did it. All right, so that is our intro, kind of the beginning of the lesson. I'll do some more videos to show you some other practice problems. Good luck. Keep at it. It's not easy, but you can get it if you work hard. All right. Email me with questions if you're having trouble. Thanks a lot.